Hello, in this video I'll be doing the demo of laboratory assignment 2 on Deterlab. This experiment is based on socket connection between two experimental nodes, one acting as a client and the other one acting as a server, and to establish a data transfer between the two nodes using the send and receive commands. So the topology setup is as shown. There are two nodes connected by a LAN, and I'll go through the ns commands as and when I do it on Deterlab. So let's go ahead and do that. The experiment setup is pretty much the same. You begin a new experiment. This would be lab 2. Description would be socket connection between two nodes, and you can choose the ns file, that is the basic ns file with the two nodes set up. I'll go through that later, and change the idle swap to 1 hour, and swap in immediately checkbox checked in, and submit the experiment. I've already done this. I'll go ahead and show the experiment. So the ns file is as follows. It has two nodes set. I'll show it in the PPT. So it has two nodes set up and a LAN between those two nodes, and the Ubuntu 16.04 OS that is being installed in the two nodes. It's pretty much the same as in experiment 1. Once the experiment is swapped in, we can see the result as a qualified name of the two nodes. We can SSH to the two nodes and transfer the client.c and server.c files that have been provided to us, and execute them as client and server. So let's go ahead and do that. So I already have SSH to node A and node B. So in my experiment I will consider node B to act as server, and to get the host name of server, you just type the host name. So this is the host name of server, node B. So we'll run the server here. We're on 4000 port number. I will try to connect this through client, that is node A / client, the host name and the port number. So the connection is established. Now let's just send this node A. So we can see that the message was received here, and it also sent, server also sent an acknowledgement back to client, and the client was also and the client also got the message and printed this. So we see that the server and the client both terminate soon after the send receive messages have been received. So we see the output as this: the client 1 sending message on the particular port on which the server is running. This is not a real world server, since the server terminates after sending out the message to client. So the enhanced server would be one that would act as a real world server, that is being open for as many as possible client requests, and also to handle multiple simultaneous client requests. So we have to modify the server code a little bit in order to accommodate this. So let's go ahead and see how it is done. So the topology setup becomes 3 nodes in order to test the simultaneous connection, and the ns file modification would be adding an extra node here, and putting the software Ubuntu on the node. So this is done, and the details of which is available here, and you can see that the node setup is done successfully and the experiment is swapped in. Now let's go ahead and see how this works. I have client on node A again and server on node B. Let's see the server. I'll go through the server code, enhance server code once. So the enhanced server code, the changes are: once the connection has been accepted, the parent process is forked into a child process to handle the connection from the client, and this is a function which handles the message transfer between client and server through read and write commands, and it closes the child connection, and later on parent connection is also closed. The server is kept open by putting the code under an infinite while loop to accept as many as client requests as possible. Let's go ahead and run this to check the connection. So we saw that node B was the server, node A as acting as client 1. Now we SSH to node C and run the client run client here as well to show simultaneous connection. So we see that both node A and node C are acting as client and node B is acting as server. Message this is node A, this is node C, and we see it, both node A and node B acting as client 1 and client 2 received acknowledgement from the server. The prompt is not returned and it's still open for multiple requests. So this shows that it can handle multiple requests and it is open for more connections. So this is the output shown: client 1, client 2 and server. It accepts multiple requests and it's open. The next thing that we go through the experiment is to check the zombie process. So whenever a parent process is forked into a child process, the parent waits on the child to get terminated. So sometimes even when the child is terminated, the parent is still in wait, and this creates a zombie process which can clog the system. So in order to avoid this, another enhancement is done to the code. So I'll go ahead and show the zombie process. So when this is run, this is without the zombie process handling. So if we can check using the command for zombie process, we can see here that the two process that is running is a zombie process, although it is the client 1 and client 2 is terminated. So in order to remove this, we do another enhancement to the code, that is to add a system call called signal sigchild ignore. This basically waits for the signal. This basically catches the signal when the child is terminated and thus avoids the creation of zombie process. So let's go ahead and see how the zombie server works. So I'll run the server on node B. And try to connect it as client 1 and client 2 from node A and node C. So this is client 1 and this is client 2. This is node C. This is node A. So we see that both client 1 and client 2 receive message and the server is still open and it handles multiple requests. Now let's go ahead and check the zombie process if there are any. So we see that there are no zombie process here. The status is not Z+. So the zombie process creation was eliminated by adding the system called signal. So this is the end of experiment number 1. In this we learned how to do a socket connection and to handle and make the server a real world server to handle multiple and simultaneous client requests and be open for many more. And also another enhancement was to eliminate the zombie process that is being created because of forking parent into child process, and seeing the demo of it. So this is it for experiment 2. Thank you.